Your applications may always work flawlessly, but sometimes I encounter exceptions in mine, and it's good to be able to handle those cleanly in the UI, as well as getting the exception logged. To force an exception to occur, I'm here in the repository code, and I'll add some logic in the remove product async method to throw an exception if we try to remove the product with an ID of 3. For sure, this is code that we're not going to want to keep when we move this app to production, but for now it lets us test how our app will behave if an exception occurs. With just that change, let's see how it behaves when we try to delete product 3. Okay, here's the app, go to products, then delete product 3. The moment of truth here is when I click delete on this confirmation page. And then we get an unhandled exception page, which shows lots of details regarding the exception that just occurred. This might be great while you're developing, but this is definitely not a great user experience, and from a security perspective, you wouldn't want to be showing this much detail in an error. Let's have another look at the code. Over in program.cs, the block that prevents the use of our error page is right here. It's only using the error page if we're not in a development environment. I generally don't recommend using that full details exception page, sometimes called the developer exception page, in any environment, including development. As developers, we should see the app as the users are going to see it, and troubleshoot errors through the logs. So let's get rid of the development condition, which should put the home error page in play here. With no other changes, let's run the app and see how the exception is handled now. Here's the app, and I'll go back and delete product 3. Hit delete on the confirmation page, and this time we see a much nicer looking error page, and it includes a request ID value that we might be able to look up in log entries. Let's go back and do this one more time, but have a look at the code and set a breakpoint. Here's the error view, which is in the shared folder, and it uses an error view model as its model. There's H1 and H2 tags using the danger CSS class, and then some code and markup for the request ID, and then the development mode section, which you may want to just remove if you won't be using the developer exception page. The route that was specified in program.cs was home/error, so if you look in the home controller, we'll see that error method. I'll make the formatting here a little better, but it just creates an error view model using the activity current object or the trace identifier. I'll put a breakpoint right here, and let's try that delete exception again. We do indeed hit the breakpoint, and if we look at the current activity object, you can see there is a lot of information about it, any of which could be included in your error page if you choose. I'll hit continue, and the error page shows up, and if we go back to VS Code and look at the debug console, the full details of our error has been logged there, including the lengthy stack trace. Going deeper than this with logging and exception handling is beyond the scope of this particular course, but now at least we have a good error page in play, and our exceptions are getting logged. That's a wrap on this module, and next up we're going to get some related data added to the database, and then update the application to use it. We've done some great refinement on our app thus far. It's using products from a database, and our views are looking pretty good. But now it's time for us to make things a little bit more interesting by adding some related data, namely a category to which a product belongs. Have a look at the table of contents for the module to see the way we'll attack this. The short version is that we'll be first making the database changes, and then we'll be updating the web application to reflect those changes, read operations first, and update operations second. And we'll even add in some more complex validation beyond what the data annotations we've been using so far can handle. This is going to be a pretty simple example, but as we go through it, I think you'll agree that the content we're covering should get you going in a number of your own scenarios. We're going to dive right into the database changes here. We want to add a new entity called a category that a product can belong to. So I'll add a new file in the data folder and call it category.cs. Then I'll paste in some code here that represents the class. It's just an ID and a name for now, but you could likely imagine some additional metadata that could belong to this entity as well. And if you can't, you'll see some before the end of this module. If you've wondered about this little warning we're seeing on some of our string properties, it has to do with nullability. And if we add equal null bang and a semicolon, We can eliminate this warning. We're telling the compiler that we know better and that the name won't be null. And now that we've defined a category entity, let's add a relationship between product and category. I'll suppress those null warnings here again to clean up the warnings in this file. And then, after the isActive property, I'll add a new nullable int for the category ID. These need to be backward compatible changes. And then I'll add a full category object as another property here. The category ID property follows the convention of using the entity name followed by ID to represent a foreign key to be used on the category object. By adding these two properties, we've added the relationship that we want. There are other types of relationships, and for those, you can check out Julie Lerman's course I mentioned earlier. Now let's update the DB context class. We need to add a new DB set for categories, and I'll do that just like we did for products. And our initial data should change just a bit as well. I'll clear out any existing categories, just like we're doing with products, to give us a clean slate each time the app starts. And then I'll paste in 2 lines that create category objects so we can refer to them as we create products. With each product, I'll set the category to one of these 2. Footwear will be the first one, and I'll copy that for the next 2. And then for the last one, I'll change it to use the equipment category. Then I'll add the 2 categories to the categories DB set and let the save changes call do the rest. That should give us 2 starting categories, and each of the 4 products should have a category assigned. Now let's open a terminal and create a migration to apply the changes. Remember that we need to be in the directory with the csproj file to run the ef CLI commands, so I'll change into that. Then we can run the .NET EF Migrations add to create a new migration, and I'll use a name of add category for it. This will build the app and create a migration based on the changes that need to be applied. If we look in the migrations folder, it now shows 2 new files for the add category migration. The interesting one is just the add category one. Let's have a peek. The up method is adding the category ID column to the products table. Nice. Then there's a new table called category being created. You can review the rest of the logic, including the down method here, on your own. But now let's run the app and make sure that the database has the data we want. Okay, the app's running and we just need to check the SQLite Explorer. Open our carved rock DB file, and already it's a good sign. The categories table is showing up in the list. And if we click the little play icon, it shows the 2 categories. Awesome. Clicking play on the products table shows us the category ID column in that table. The first 3 are 1000 for footwear, and the last one is 2000 for equipment. Nice. Let's continue with our updates. Here's a quick but important aside regarding the database that isn't updating the site, but rather improving its ability to be deployed to other environments. You may have noticed that the file name for the database is hard-coded into this constructor here. Most often, you would have some kind of connection string that's provided by configuration. So let's do that now. We'll just use the file name since we're using SQLite, but you'll quickly see that this could apply to a full connection string as well. I'll copy the file name value here, and we'll use that as the configuration value that we'll define. In the app settings JSON file, we can put information that will be made available to the application when it starts up. Configuration values can come from environment variables and other places too, but for now, I'll add a special section to this JSON doc for connection strings, and in it, I'll add a key called product.db file name, and I'll set the value to that file name we copied. Then I'll copy this key value so that we can refer to it, and if you're wondering about how this configuration is made available, at the top of program.cs, here's the line that calls webapplication.createBuilder. The default behavior of this code is that it'll set up some basic logging and also basic configuration providers for you. Getting into the details is beyond the scope of this course, but the app settings JSON file is read in as part of the configuration pipeline. It can be overridden by environment-specific app settings JSON files, environment variables, and even command line args. But now that we've got the configuration added, and this default code will load it, we can inject an iConfiguration object into the constructor for our product context. And then we can use the injected config and its getConnectionString method with the key name that we just copied to get that value from the connection strings section within the configuration file. I put this on another line to make it easier to see, but it looks like it'll fit on the original line just fine. So yeah, let's run this again with our DB name coming from config, and it should behave exactly the same. Here's the running app, and the products page does indeed show the list of products from the database. So moving this hard-coded string into configuration worked. We've definitely only scratched the surface of using configuration here. So note that there's a link to the configuration documentation in the project README, and you can also check out Steve Gordon's excellent course, Using Configuration and Options in .NET Core and ASP.NET Core apps, to learn more. But now let's keep moving and add the ability to do CRUD operations on categories. Now we're going to take advantage of that scaffolding functionality once again, this time for CRUD operations on categories. And this time, instead of using Rider or Visual Studio, we'll use that command line tool I mentioned before. It's .NET ASP.NET Code Generator, and I've already installed it. But here's the command you can use if you want to follow along. Or you can add the scaffolded item in Visual Studio or Rider. This tool will build your project and needs to be run from the folder with your CS_proj file, so I'll change to that directory. Then I'll run .NET ASP.NET Code Generator controller-h to see the options we can provide when doing this. There are quite a few options here, but the ones we really need are the controller name, the model and data context, the controller namespace, and the use default layout, since we want these new pages to use our standard layout. So let's go. .NET ASP.NET Code Generator, controller, and our controller name will be categories controller. The namespace will be carvedrock.admin.controllers. The model is carvedrock.admin.data.category. Don't forget the namespace on the model and the data context. And the data context is going to be carvedrock admin data product context. Finally, I'll add the use default layout flag, and that should be good. The project gets built, and the output tells us exactly which files were added. All of this looks good, except the categories controller was put in the root directory. I'll move it into the controllers folder, and then let's have a look. The constructor is injecting a product context directly, and this is likely an area where you'd want to go through some refactoring, just like we did in the earlier module where we added the repository and logic classes. I'll leave that as an exercise for you, but using this scaffolding, we should have a working starting point for managing categories. Looking at the Create view, it's referencing the data entity directly, but the view content looks good, very similar to what we've already seen for products. Let's modify the main layout page to have a link for categories in the navbar. I'll get down to the navbar section, add a space after the products nav item, and paste in a similar link called categories that references the categories controller. Let's run it and verify that we can edit categories. The app comes up fine. We'll click on the new categories link, and the list of 2 categories comes up. Nice. The create link is just a link. Feel free to convert this to a button like we did in the last module, and clicking it brings up a view that's just prompting us for the name, since the ID is going to be automatically set. I'll type clothing and hit save, and it works just fine. This new item is there in the list now, but when we start the app up again, we'll just have those first 2 categories since our startup logic resets the dev data. Let's get the category into our product functionality now.